Is introduce the actually creator of Wireshark, A Trillion Truths, Gerald Combs.
Hi. I will say at the beginning, I have a tendency to talk fast and mumble. So if I do, don't hesitate to speak up and ask me to repeat something, just in case you miss anything. But so why am I here? I'm the Wireshark guy. I'm not the Nagios guy. I do use Nagios, to monitor the Wireshark infrastructure, but I'm by no means even Nagios power user, much less an expert. But I do have a lot of knowledge and love and PowerPoint slides that I want to share with you today that you might find relevant and interesting. So without any further ado, let's get started. This is what Nagios looks like when it monitors the Wireshark infrastructure. I don't really do anything in Note except, I'm running Coffee Saint, and I set it up with a font that's kind of like the one Kubrick used in 2001. And I use the title Homicidal Robot Menace just because I want to set the proper sense of urgency when there are problems on the network. And yeah, that's my extent of Nagios knowledge to give to you today. So, but there's a question. What's happening on your network? And Wireshark tries to answer that question at one level, and Nagios tries to answer it at a completely different level. But this is actually a question that has shaped my career, and probably the careers of a lot of people here. I started out working, it's funny, when Ethan was talking about the origins of Nagios, I was kind of counting off all the parallels between what he was doing and what I was doing. I too started out at a university. I was in the Midwest. I was down in Kansas City working at UMKC in their network computing division, and I had to troubleshoot the network. And so they gave me this box about this big. It was this compact, luggable computer called, it was called a sniffer. It was a really fancy sniffer because we had 10 meg Ethernet and Token Ring and FDDI, and it was really fancy, and it weighed 4 tons, and I had to carry it around campus and plug in and do network troubleshooting and look at packets. But that's how I got started in the industry, that's how I got interested in looking at packets and ultimately ended up writing a protocol analyzer. But so what's happening on your network? Well, packets. Let's see if I can find the pointer. Suppose Nagios, bringing it back to Nagios, suppose Nagios is paging you and it's a network issue, and you are confronted with this. Is this the cause of your problem? Well, if I see a packet dump like this, I scan across the first line, and I get down here, and I see 00045. And I think, oh, great, we're running IPv4 over Ethernet. Because 000 is the Ether type for IP, and version 4, and header length of 5 gives me 20 bytes. And if I scan down here, I see number 6. OK, this is a TCP packet, and we can go in and dig through and find TCP flags and IP addresses and Ethernet addresses. And how many people analyze networks this way? Most people, I'm happy to say, use Wireshark. And if you take this packet and give it to Wireshark, you get, well, hopefully a better, more readable image than this. But you get what you see in the middle here. You get the protocol tree, that the middle pane in Wireshark, which you can expand out. And Wireshark will take every bit and byte in the packet and show you in a way that's easy for humans to understand what everything in that packet means. And Wireshark does a better job of this than any other product in the world. And that's due to the efforts of a lot of really talented developers. And it's a real honor for me to be able to work with Wireshark's development team. So what is Wireshark? Wireshark is 2 things. First and foremost, it's a dissection engine. And I picked, early on, I chose the word dissection very specifically because other products use the term decode. They had packet decodes. Well, Wireshark has dissectors. I wanted to be very specific and be really clear that we're taking every bit and byte in that packet and ripping it apart and categorizing it as much as possible for you. And this is kind of the part of the code where we define our header fields, which are what each line in that protocol tree mean. Wireshark spends a lot of time filling in this header field. And that's its job to dissect packets. My job is to make this dissection engine as useful as possible to as many people as possible. And hope I'm doing a good job. But Wireshark is another thing. Wireshark is a community. Much like Nagios, it has a community which is well represented here. It's really cool, coming here and seeing this. Wireshark, we also have our yearly conference, and this is a picture from a couple of years ago. And my other job is to make sure that this community has the tools that they need to do their jobs. So, who makes up Wireshark's community? Well, I'm not going to read off every bullet point here, but the interesting things to me when I go out and meet users is that everybody in a particular field thinks that Wireshark was made for their field. Like the security guys think that Wireshark is a security tool, and professors think that Wireshark is an educational tool, and so on. And the other thing is, this tweet here is from a guy named Daniel Stenberg. Daniel wrote curl, the command line URL tool. And he now works for Mozilla, and I thought it was really cool. They were recently using Wireshark for interoperability and validation testing for the HTTP2 protocol. And if you're writing software that implements a brand new protocol, it's a really easy thing to go and jump over and add a Wireshark dissector. And so this is actually a pretty common use case. So I mentioned, I started out at a university with a sniffer, and after that I went to an ISP in Kansas City, and we didn't have a lot of money, but I still had to troubleshoot the network. We had clients like AT&T and Apple and the Kansas City Chiefs and Ditch Witch and so on, and I had to troubleshoot and find problems. And so I finally broke down and started writing my own protocol analyzer, and that's how initially Ethereal was born. That was the first name of the project. Much like Nagios, we changed names at midpoint. But back then, right now today, if you want to start an open source project, you need to do 3 things. You go to GitHub and create an account, and then you check in source code, and I lied, you're done, there is no step 3. GitHub and even SourceForge and Bitbucket and all these other places make it really easy today to go start an open source project. However, back then, it wasn't so easy. These sites did not exist, even SourceForge. And so I ended up buying my own server from this brand new website called eBay, and going around town and trading consulting time with ISPs and so on. And the thing is, like I said, if you're a small project, it's really easy to start an open source project. If you're a large project like Firefox or Apache or the Linux kernel, companies will throw money and people at you left and right. And so they don't have a problem like I do. But the thing is, if you're a medium-sized project like Nagios or Wireshark, you probably are too big for GitHub. Like in my case, I have this huge automated build system that GitHub ain't going to give me. I have to pay for those servers somehow. And I had bandwidth requirements that cost a lot of money. GitHub, they started out hosting software downloads, and then they took that away when everybody started using it actually using it. To support this and make sure that we can continue to serve our users, we had to come up with a business model. And I don't think Ethan's here, but I'm sure he had to go through the same stuff. So, like I said, in the early, say, 99, 2000 or so, I was moving the box around. Ultimately, I ended up hosting the project where I work, which worked out for a little while. But the thing was, when I started the project, I initially targeted Linux and Solaris because those were the operating systems that I used. I didn't use Windows. I thought it was dumb. I had no plans to support it. However, in Italy, there are a couple of grad students who took the libpcap packet capture library, and they ported it to Windows and called it WinPCAP. And one of our developers said, hey, we can port Ethereal over to Windows using WinPCAP. And suddenly we got really popular, and people actually use Windows. I mean, who knew? So we got really popular, and around the mid-2000s, wireless got really popular. But in the mid-2000s, wireless wasn't reliable at all. And so we had a lot of Windows users sending questions to the mailing list saying, OK, I'm trying to do packet capture on Windows. And the thing is, if it's 2004 or 2005, and you're on XP, and you fire up Ethereal, and you say, OK, capture packets on this wireless interface, something really interesting happens. And that interesting thing is that your wireless driver shuts off the radio. For whatever reason, promiscuous mode at that time meant no packets. So by that point, the guys who wrote WinPCAP, Loris and Gianluca, they had moved to Davis, California, just outside of Sacramento, and they joined a company and started up a company there. And I sent them an email, got in touch with them, and said, look, is there any way we can solve this wireless problem? Because at that point, the standard answer for those questions about wireless capture were, go install Linux, you loser, ha, ha, ha. This is a bad answer. So I contacted Loris and Gianluca, and said, is there anything we can do? And they said yes. And we ended up developing a product called AirPCAP, which is this little USB stick, USB wireless stick and a special driver that lets you do packet capture on Windows. And they invited me to come out and actually join the company, and I did. And that's why we actually had to change the name, because my former employer owned the trademark for Ethereal. And we just couldn't come to an agreement on transferring it, so we had to change the name. And in our case, we came up with a short list of candidate names, and I showed it to my wife, and she picked Wireshark. So if you like Wireshark, think Karen, my wife. So, but the thing is, this is where we found our business model, our sustainability model for the project. And that is to develop products that complement Wireshark and WinPCAP and support them. And that's what we did. Shortly after AirPCAP, we came out with a product called Pilot, which is a higher level analysis tool that lets you, sift through packets really quickly and send interesting ones down to Wireshark. And we developed a packet capture appliance called the Shark Appliance, and so on. And in 2010, at SharkFest, this company I'd never heard of named Riverbed came to SharkFest, and they liked what we were doing, and they had some products that complemented what we were doing, and they ended up buying us a few months later. And this is where I work today. Riverbed is my employer, and Riverbed is the primary sponsor of Wireshark. And the reason I'm talking about business models is because if you really like Nagios Core, if you use it every day, go buy stuff from Nagios Enterprises. Buy those products that support the tool that you use. It's really important to make sure that that project continues. So enough about business models. I couldn't think of a better title for this section, so I'm just calling it Finding Network Truths. Like I said, Wireshark and Nagios both try to tell you what's on your network. They just kind of do it from different vantage points and use different methods. But I want to complain about the 5-minute graph. I want to be clear up front. I'm not complaining about RED tool. I love RED tool. I'm complaining about this particular use of RED tool. A couple of years ago, in 2012, I think it was, at SharkFest, I went up on stage and gave a talk and got off the stage, and one of our developers said, I can't check in any source code. And I went and looked, and sure enough, all of our websites were down. For some reason, somebody thought it would be an awesome idea to launch a denial of service attack against all of our websites during our user conference. So I contacted my colo provider. I said, I think we're under attack. And they sent me back an RED tool graph that looked like this, and they said, we don't see a problem. And I said, have you looked at the packets? And their answer was, well, we don't look at packets. Really? I thought that was an awful answer, personally. But here's the deal. Like I said, RED tool is great. 5-minute graphs are great. But that shouldn't be where your troubleshooting stops. That should be where your troubleshooting starts. Can anybody tell me how do we get points on this graph? In this case, we're looking for input and output octets, so we send an SNMP query over to our router or switch, and we say, okay, give me your input and output octets for this interface, and it sends us back 2 integers. And then we wait 5 minutes. I'm not going to wait 5 minutes. And then we do it again. We ask for those two numbers, and we subtract that numerical pair, and we have a couple of points we can draw on a graph. That's over 5 minutes. So what happened over that time span? Anything could have happened. What did that traffic look like? We don't know, because we threw away a whole bunch of information just now. That time interval might look like this. I actually had a client whose network, their traffic looked like this. It was the same amount of traffic at all times. They worked really hard to make sure that their network looked like this. I don't know anybody else that does this. Maybe it looked like this. Your network was at 0 for some amount of time, and then it was maxed out 100% for some amount of time. I've not met anybody that does this. And I'm showing off my awesome MS Paint skills here, but most of the time it looks like this. You have a little bit of traffic at some point. Sometimes you're maxed out. If you're a financial trading house, maybe you have, well, everybody has microbursts. But if you're a financial trading house, you care about microbursts. If you don't know what microbursts are bursts of traffic over the span of a few milliseconds that fill up your switch buffer. And if you have time-sensitive protocols like financial protocols, this is a really big deal because you lose money, effectively, in their case. But the thing is, when my ISP sends me this, I don't know what my traffic looked like. Luckily, and I'm not trying to do a sales thing here, I'm just showing you, just in the interest of eating our own dog food, I have my company's products at the Colo site. And so I had a capture appliance. I was able to go back a couple of hours when the attack happened and pull up, do some analysis and pull up some traffic. And this is what it looks like actually in Pilot. These are the TCP send packets over time. And let me try to use the pointer. I usually use my hands. But down here we have our baseline, which is the normal traffic levels that we see. And we just, I don't have the most popular website in the world, so I just see a few sends, maybe a few sends per second coming in. Then suddenly the traffic ramps up, it kind of drops down a little bit, then it ramps back up again. I forget what the actual numbers are, but it was something like, I don't know, 100 or 200,000 sends per second coming into the network. This was not enough to max out the connection, but it was surely enough to max out the translation tables on the crappy firewalls I was using at the time. And this killed our websites. And so, if I then go and select maybe half a second or just a couple of seconds of time and send that to Wireshark, I saw this, and I was able to verify, OK, these are all send packets. And I was able to send this back to my Colo provider and say, look, there is a problem here. And like I said, your 5-minute graph are not where your diagnostic stops, or your troubleshooting stops. It's where it starts. And in this industry, I was even talking to you about this yesterday, there's a phrase, the packets never lie. I don't know who came up with it, but it's a popular phrase and a lot of people use it. And it's true. The packets that are on your network are what define your network. You have this underlying infrastructure of switches and routers and whatnot, but the packets actually are what your network is doing. The thing is, the packets might never lie, but you get different truths depending on where you look. If you look on the inside and outside of a firewall or some NAT box, you're going to see a different set of addresses. If you look on the wire versus deep down in the bowels of a VM server, you're going to see different things. One of the questions we get all the time right now on our Q&A site is, OK, I'm capturing on Ethernet, but I'm seeing 64 kbyte packets. This is bigger than the maximum Ethernet frame by far. Why is this? And the answer we have to give is, well, because your either virtual or physical NIC is doing offloading for you and trying to be helpful, it's gluing a whole bunch of packets together. So what you're seeing is not what's on the wire. Yeah, it's what your host is seeing, but the truth is different depending on where you look. The other problem is right now, especially in the clients I deal with, it's easy to end up with a trillion truths, meaning if you have a bunch of packet capture appliances, gathering packets, and you have a bunch of them deployed, it's easy to end up with literally 1 trillion or 2 trillion packets. And as the creator of Wireshark, I don't want you looking at 1 trillion packets. I want you looking at 5 interesting ones. And the trick is to sift through that haystack and get down to the needles that you want to see. And that's basically where my company spends a lot of time and effort building products. So how do you capture? You can capture at 0 scale, meaning you fire up TCBump, say, try it now, and then the person says, okay, I tried it again, but it's still broken. And then you have to explain that, okay, you're still gathering data, it's still gonna be broken, you haven't solved it yet. Then you copy the traffic back and you look at it in Wireshark. This works, I do it occasionally, but it doesn't work if you want to go back in time or in a number of other circumstances. It works only if you can duplicate the problem at any given time. So what a lot of companies do is they set up programs for network visibility. They start gathering flow data and packet data, and they start installing appliances to capture all this stuff. And they have a goal. And this was the dumbest chart I have ever made, but it's what you want. You want everything from flows down to bits, and you want it from right now to back to caveman times, just so that there is a problem. If there was a problem last weekend, you want to be able to pull up flow and packet data and go troubleshoot that. But the thing is, I keep saying one client, but there actually is one client here that I talked to a couple of times, and they are really dedicated to doing this, and they actually do a pretty good job of it, but it requires a lot of time and effort and expense. Most people end up with something like this. You have flow data going back from now to the dawn of time, because flow data is pretty small, it's summary data, and you can keep that around. You don't have packet data because it uses up a lot of disk space and it's hard to capture. And then you have gaps because the security team stole your span port one day, and you didn't realize it, and then you made them give it back. I know that never happens. But so you end up with all these gaps and stuff. And so, like I said, getting here actually can take a bit of effort. And the thing that I'm talking about here is, the name is called retrospective analysis. You can set it up on the cheap. You can grab a laptop and set up some disks on it, or an old server, and throw some disks at it, and set up a span port, and then you set up dump cap or TCP dump. You might not know what dump cap is. Dump cap is the thing in Wireshark that actually captures packets. When you're in Wireshark and you say start capture, it actually fires off a dump cap process, and dump cap is the thing that talks to the OS and pulls packets out. Wireshark, when you install Wireshark, you actually get the GUI, but you also get a ton of command line utilities. And if you haven't looked at all these utilities, you should. In particular, tshark, which is the command line version of Wireshark, and dump cap and edit cap, and which lets you convert file formats, and cap infos. If you have a directory with 40,000 capture files, you can use cap infos to get summary information about every one of those really quickly. Anyway, we don't have any Riverbed salespeople in here, so I don't have to worry about making them cry, but this actually works, the cheap solution. You just set up a cron job and start capturing packets, and if you haven't done so, it might be like an afternoon project to try out. But beyond that, you get into dedicated appliance territory, and you get into problems that we've actually already solved with our appliances. Some of the problems that we solved are the file system. The standard, most standard operating system file systems are file-based. And what we actually ended up doing on our boxes was writing our own time-based file system and our own flow indexing system, so that if I want to capture traffic for just this host or just this port over this specific time span, I can do that really quickly, due to that meta index in the file system. We found out early on with mechanical disks that if you get about 20% away from the end, write performance goes into the toilet. So we just don't write at the end of the disk. We reserve that portion of the disk. what are the things? We added our own high-level analysis system so that if you have a capture appliance at a remote site, you don't have to transfer back a terabyte of data. You just do a little bit of analysis on the far end and pull back a few megs that you can easily load up into Wireshark and so on. Just all these different problems that we had to solve building this stuff. And like I said, the more packets you want to capture, the more disk you need. I mean, you can kind of get around that by saving only the first, say, 120 bytes per packet and so on. But packets use disk. That's just one of the truisms. Talking to the people here, I don't think, I haven't met anybody here that does networking stuff, so I'm not going to go into ports versus taps in any detail. But I will say taps are better than ports if you can afford them. But they are extra cost and extra hardware, but they do stuff like timestamp your packets for you. It's awesome. But the thing is, ports and taps are the old kind of classic hardware solutions for getting at packets. But the reality is you really need to do stuff like VM capture and cloud capture. The trouble with VM capture is, if you try to do it on the VM host, you're choosing to kill performance for all the other guests because packet capture just takes a lot of resources. If you want to do local storage on your VM server, you've just killed disk performance. So a lot of people will take that traffic and ship it out through some extra interface. But then you have to have an extra interface. So this subject is actually pretty complex and warrants its own session or two. And there's a guy named Jasper Bongertz who comes to Wireshark, and he talks about VM capture all the time. But if you want to learn more about this, he has a couple of blog posts that go into VMware packet capture in great detail, and they're great articles. And now we're to the cloud, which is much like VM, but more sucky. If you want to capture packets on say, EC2, you're back to using TCP dump or dump cap, which I don't like, and I don't like it for a very specific reason, because I haven't visited Amazon yet, but I've visited Microsoft. And Microsoft, to monitor their networks, they have this huge public-facing network, actually probably several. But the one I saw, a guy, he doesn't work there anymore, but his name was Rich Groves. And if you care about large-scale packet capture, you should look up Rich Groves and Daemon, Google for that. What he ended up doing was, they had all these Arista switches on their edge, and he ended up writing this SDN solution called Daemon, the distributed Ethernet monitor, and he was then able to say, okay, for this interesting traffic that I want to see, all my public-facing switches, if you see this traffic, if you match this, copy those packets down to the set of collection switches. The collection switches then do fancy stuff like add timestamps, and then that's passed on to a packet capture appliance or two. And it's an awesome and really cool thing. I've seen it in person, and it's a great, I'm really impressed with what he did. But the thing is, and there's a company called Big Switch. They have something called Big Tap, which I guess is the commercial version of this. But what annoys me about this is I'm assuming that Amazon has something similar on their system. They need to troubleshoot their network, and they have a huge network. But I, as a client, do not see this. How hard would it be for them? I'm assuming they use merchant silicon, which that stuff can duplicate packets really easily. How hard would it be just to add an option to copy my traffic to this other port when I'm setting up an Amazon VPC so that I can do actual monitoring? I guess none of their customers ask for this, so they don't add it. But from my perspective, I really want it, and I don't think it would be too difficult. Can you please do it? So anyway, enough about me complaining. So if you fired up Wireshark for the first time, maybe you saw something like this. This is actually an A380 cockpit. You get this big window with all these knobs and buttons and switches and packets and dials, and you don't know what to click on and how to go about solving your problem. Wireshark, like I said, it'll show you everything about every packet that it sees, and it does it really well. But the problem is, actually being able to go through and use that effectively to do troubleshooting or whatever you're trying to do. I'm not here to teach a Wireshark class today. I can and I have, but there are other people that do a better job, like Laura. But if you're the kind of person that takes pictures of slides, this is the time to do that. Probably the two best places to learn about Wireshark or to get help are a question and answer site, ask.wireshark.org. And you post a question there, and most of the time somebody will answer the question. And I say most of the time because there are people who actually hang out on Ask, and they answer questions in order to pad out their resumes so that when they go to a prospective employer, they can say, look, I answered all these questions, and I answered them really smart, so you should hire me. And Laura Chappell, if you have not seen one of her webinars, she does Wireshark training, and she writes books, and she handles our certification program. But every once in a while, she'll do a free webinar series. And if you have the chance to join one of her webinars, you should. She's great. She's a great instructor. If you want to learn protocol analysis, she's the one to go to. And I don't want to push our own conference, but we do have one. It's called SharkFest. Also, Hansong Day. Hansong is a coworker of mine, but he used to be in charge of network troubleshooting at Citigroup. And he has seen just about anything that can go wrong on a network. And he's just this huge, great resource, this great wealth of knowledge about network troubleshooting. And I actually, go on trips, client trips with him to talk to clients and stuff. And he's great. But he has blog posts both at Riverbed and the Wireshark websites. Tim O'Neill's been in this industry for literally decades. He was there at the dawn of the industry, and he has a bunch of really great stuff on his websites. And Jasper, who I mentioned before. OK, we're about 30 minutes here. So I'm just going to skip over these slides. But there was this article I saw a couple years ago called "It's Still the Latency Stupid." You can barely read it there. But they were referring to an article that was actually written in 1996 and titled "It's the Latency Stupid." And it was written by a guy named Stuart Cheshire. He's really smart. He developed a lot of zero configuration protocols after this. But at this time, he was writing a computer game, and he noticed that no matter how much bandwidth he had, performance still was awful if he had poor latency. And he wrote this big, long rant about latency. So, OK, we knew about latency in 2012. We knew about it in 1996. We knew about latency in 1976. This is a document called the Xerox Wire Functional Specification, written in 1976 by a guy named Bob Metcalf. This is what eventually became Ethernet. And on this particular review copy, at the bottom, somebody wrote latency? So this is a problem we've known about for a long time, about 40 years now. And yet, I have the set of standard SNP nibs on my laptop. And if I go looking for the word latency in there, I don't find it. We have all sorts of things to track bandwidth and up, down, and so on. But we don't have a lot of standard foundational things in network monitoring nowadays for tracking latency. And I think that's a terrible thing. I mean, Nagios can do a lot to solve that and to monitor that. In fact, when I monitor the Wireshark infrastructure, I really look at response time and latency. But I can't go query a router or a switch for latency like I can input and output octets. And I think that's a crying shame. So I got, 5 minutes? 15. OK, good, because I have a demo I want to do. OK, I think I'm done complaining for a while. But so, I talked about the origins of Wireshark. Wireshark right now today is in a good position. We have this nice company sponsoring us and a great group of developers. I'm not going to read off all these stats, but the one stat everybody asks me about are the number of downloads we get per month. I would do this if we had 10 users versus a million, but the thing is, the number I always used to use was 500,000 because that was the safe number, the guaranteed number we would have even on a slow month. But now that number's kind of gone up to 1 million. And that's partly due to natural growth, I'm sure, but it's also because I enabled automatic updates in Wireshark a while back. So everybody downloads it automatically. These are not people that are consciously going and doing this anymore. So I hate giving out this number because I don't know what sort of knowledge you can infer from it, because this is just the number that I can track from the Wireshark websites. I can't track other download sites, and I can't track, say, Linux distributions and so on. So I hate giving out this number, but everybody asks for it. The other thing is, your network is not a black box, like it says down here. I wish I had come up with this, but I didn't. Actually, a guy named Scott Hanselman did. He wrote a blog post titled "The Internet is Not a Black Box," and he encouraged people to go look and figure out how the network works at a low fundamental level, because it's not magic, and once we start treating it as magic, then things are going to go wrong. And I totally agree with him. Your network is not a black box. I'm, of course, biased, but I encourage you to go look at packets once in a while, just to see what your network is doing. So what's next for Wireshark? Ooh. Here, let me go to the next slide. Right now, we have some things that are a struggle for me. There's an irony here. I and a lot of Wireshark core developers use macOS. Yet macOS gives you the worst user experience of all the platforms that we support. Laura Chappell, if I sit in on one of her webinars, she always gives me trouble, but one of the things she always asks for is she wants to see Wireshark on her iPad. And I give her a really funny look, because I know that would be useful, but I have no idea how that would actually be implemented. And I go and think about how we might do that, and I still haven't come up with an idea. I've already complained about the cloud, but they're working on 400 gig Ethernet right now, which should scare everybody. It scares me, because even a half a second at full rate 400 gig is way more than Wireshark's going to be able to handle. And the bottom one, if you want process information, this is something I've always wanted in Wireshark and haven't been able to come up with a good solution. When I click on a packet, I want to see not only what's in the packet, but I want to see what application and what user, and even if I can, maybe a little bit of a stack trace to see what functions and methods generated that packet and are associated with it. Loris Dejouani, who he created OnePCAP, he has actually started a new project called SysDig, S-Y-S-D-I-G, and you should look it up, because it's pretty cool. If we're going to tie process information to packets, SysDig would be one way to do that. Anyway, to address the first item, a while back I started porting Wireshark from GTK, which was our original user interface toolkit, over to Qt. This will not only make things better for macOS users, but it'll make things better for Windows and Linux users, because along with this comes a better UI toolkit and a more modern interface. And I don't know if you guys read Hacker News, but it's a popular tech website, kind of like Slashdot and so on. But one day I wrote this blog article about switching Wireshark over to Qt. It actually was almost exactly a year ago. And I posted the blog article and didn't think much about it. But then, shortly after that, we made #1 on Hacker News. Hacker News, the articles are voted up by the users. And so this community thought this was important enough to make us #1 on the website for, I don't know, 3 hours. But the thing is, just to get a sample of things that interest the Hacker News community, okay, that day they cared about Wireshark, cryptography, drugs, cryptography, computer games, computer language, and a development environment. So I don't know what this says about the Hacker News community, but I'm sure you could derive something. OK, looks like we have enough time for a demo, maybe 5 minutes. So I'm going to try to switch over to there. All right. So this, oh good. this is the new Wireshark interface. And if you go download the development version 1.99.0, this is what you'll see. And I don't think the main window, if you use the current version, you'll notice the main window is completely different. It's a lot more sparse. And I wanted to kind of start from a clean slate and build up from there and only add useful things. But you'll notice there are 3 big, huge buttons on the side that you can use to look at your capture interfaces or your recently opened files. And there are strip charts. One of the things that I always end up doing is in the current interface, I'll pull up the main window, double click on an interface to start capturing, and I don't see any packets because I picked the wrong interface because there's no traffic on that interface. And so I added some spark lines, the little strip chart that you see here, so you can see what's actually going on each interface. Also, on the left-hand side, there are 3 huge buttons, and I made them huge because of something called Fitts Law. If you go look up Fitts Law, F-I-T-T-S, on Wikipedia, it's a law that says, get ready for this, the closer a target is and the larger it is, the easier it is to hit. It took from the dawn of human civilization until 1954 for somebody to formalize that notion, which I find fascinating. Tell you what, I'm going to open up a capture file. This is the new interface. This is not too different from the old interface. Apple's famous for wanting to make products that are insanely great, or Steve Jobs, in a couple of cases, is quoted as saying he wants a product that'll make you crap your pants. I would be happy with pleasant surprise for the new interface. That's my goal, pleasant surprise. And I think we're getting there. This is a capture from, let me resize the columns. I think this is an interesting capture. If you haven't used Wireshark's follow TCP stream feature, you should. You right-click on a TCP packet and say follow TCP stream, and you can see what the client and servers are saying to each other. In this case, this is a fascinating thing because I spun up a new download server for Wireshark, and I made it HTTPS only, SSL only. And OK, what do you see here? Plain old HTTP. I got a lot of requests from this one particular part of the world. They're trying to fetch an SSL URL over plain old unencrypted HTTP, and they kept trying and kept trying and kept trying, so I made this capture. But if you use Wireshark's follow TCP stream window, in the new interface, you can actually click down here and go to the next and previous stream, which is kind of useful. Here, let me close this. We also have a ton of interesting new features, but yeah, let's pull up this one. This is going to take a couple of seconds to load, but there we are. I want to show you Wireshark's new I/O graph. It'll take a few minutes to load again. This is our new I/O graph. If you used our old I/O graph, you could get usable data out of it, but it was just more difficult. And that was because of the old toolkit that we used, GTK. Qt has actually a third-party library called QCustomPlot. But it makes graphing a lot easier. And so now we have this graph. The black line is all packets in the packet capture, graphed in packets per second. And then we have TCP errors, which match the display filter TCP.analysis.flags. If TCP.analysis.flags is set in a particular packet, that means you have problems. And that's what I have graphed in the red bar chart. And just to show that you can name a graph anything and graph anything, I have UDP length graphed out as a graph name I like potatoes. And those are the green dots. The new graph also lets you save out in different file formats. Like I can save this out as a PDF or PNG or JPEG or so on. So as you can see, if you're used to using Wireshark now, these are not huge leaps and bounds that are different from the current interface, but it's much like the current interface, only it's more usable and more pleasant to use and easier to use. One last thing. There are a lot of new features that I could spend half an hour showing you, but the one thing I tried to do with the preferences even, the old preference window had all sorts of, every preference that you could set was there. So you had this huge busy window with a bunch of crap in it that you didn't care about. And so what I did was strip most of the crap you don't care about out and leave the important stuff in. But if you do want to get to everything that you can set, you can click on the Advanced tab, and it's a lot like bringing up about:config in Firefox, where you can see all the settings for the product. And you can see what's changed and what the default values are and so on. You can zoom in, zoom normal, and so on. So I'm working on this. I'm trying to make it better, and this is what the next version of Wireshark is going to look like. And I'm being warned that we're short on time, so let me try to wrap up. Just to wrap up, I always like to close my talks with a picture of the goat. I think it's a goat. I'm a city person. I don't know what this is. As a hobby, I do road biking, meaning I get on a bicycle and I go out and ride in the country until until I'm about to keel over, and then I ride back home. But I grew up in Kansas City, but now I live out in the Central Valley in California, outside of Sacramento. And if you've ever been there in July, it's really hot and dry. And so on the weekends in the summer, I go out and ride and dehydrate myself, and which is a very dangerous and unhealthy thing. But one day I was out riding, and I came upon this goat. I think it's a goat, like I said. And he's resting in the shade. And here I am in the sun, losing all the fluids in my body. And if you take those two facts, you can infer that I'm dumber than livestock. I like to close with this because Wireshark is a great and wonderful thing, and it's not because of me, it's because of you. It's because of the user community, it's because of the developers and educators and trainers and the entire Wireshark community. And it's a really great honor to be able to work on this project, and I have to thank you. I can't thank you enough, and so thank you.
All right, we do have a little bit of time for a Q&A. Is there any questions?
I love the tool. Thanks again for the presentation.
Oh, thank you.
But those of us that use it in the real world often jump onto a network. There's no pre-existing infrastructure, no capture devices. Any words of wisdom for us in terms of gathering data?
Well, this is the point in the talk where I hand it over to a Riverbed salesperson. But when you're out dealing with clients and and you need to do stuff like retrospective analysis, if you get to a site and you've already missed the traffic that's interesting, it's gone. Unless you can replicate that problem, you're kind of limited in your choices. But like I said, I would encourage you, even if you just set up an old spare server with some disks and capture traffic for say the previous 4 hours, even that's helpful. And even setting up flow analysis, which which you can buy a solution from Nagios to do that. Flow analysis even helps. I've used that in the past. Since I needed to find out what one of my servers was doing 3 months before, and I was able to use Flow to do that. So any sort of gathering and any sort of packet capture that you can do is going to help. But yeah, just even if you set up an old box or an old laptop to do that.
I was just curious, do you have a way to do like a 4-hour buffer capture, just keep that ongoing?
Well, that's what I was talking about before. Some people just set up an old box with some disks, and you set up a cron job using. I recommend dumpcap because dumpcap has the ability. It has command line options to do what are called, we call them ring buffers, but they just rotate through packet captures. And the thing that DumpCap does is timestamp them, and then Wireshark can recognize the timestamps and create what are called file sets, and you can jump between the file sets. Beyond that, if you're looking for even more capabilities, my company sells really nice packet capture appliances that let you do all sorts of awesome and cool things, but this is not a sales presentation, so.
Yeah, DumpCap actually interests me because I'm sitting there thinking of real-world troubles where you have an end user on their home network and now they're trying to do video and SIP calls and the quality's not there, they're dropping calls. So if I'm starting a remote support session with them, besides downloading all of Wireshark, is there a way I can just send them DumpCap and say install WinPCAP and then capture a file and then fetch it back?
Not really. I mean, it's usually not a big deal to go and
get Wireshark.
And get Wireshark. In fact, we have a portable version that'll work with portable apps. If you're familiar with that, you can just download the portable version and run that, as kind of a one-off. The thing is, you still have to have WinPCAP installed to do the capture, but you can kind of do that remotely.
Any other additional questions? All right, well, how about a nice big round of applause for Gerald Combs. Once again, thank you so much, Gerald. Appreciate it.